Welcome back to the third part in this series on integration. In this video, we're going to look in particular at integrating functions that have a form ax plus b to the power of n. So looking at the rule we have, when we integrate ax plus b to the power of n with respect to x, we have 1 divided by a, which is the coefficient of x, times n plus 1 on the bottom of this fraction, and then we still have that multiplying ax plus b, and then we have to the power of n plus 1, so we've added 1 to the power, and then we have this constant of integration that is added on, and this rule will apply for any n that isn't equal to -1. So now let's have a look at a couple of examples of applying this rule. So for our first one, we have the integral of 2x plus 1, so that's a linear term, which is what we require to be inside, to the power of 4, and we're going to integrate that with respect to x. So when we do that, this is going to equal, and applying our rule, we're going to have 1 divided by, and we have the a term, which is the coefficient of x, so in this case that is 2, so we're going to have 2 times, and then when we add 1 to this power, that's going to be 5, and then we're still going to have the 2x plus 1, and now it's going to be to the power of 5 once we've added 1 to that power, and we have a plus c value. So this is going to equal, and we can just simplify it slightly, 1 divided by 2 times 5 is just 1 divided by 10 times the 2x plus 1 to the power of 5 plus c. So that's the answer to part 1 of this question. For part 2, we're just going to do another definite integral. So this time we have the integral of 6 divided by 2 minus 5x to the power of 4. So this time the 4 is on the bottom line. So we're going to have to do something with that before we can apply this rule. And that is going to be integrated with respect to x. So now this is going to equal, and we're going to have the integral of 6 times 2 minus 5x to the power of, and now instead of having 4 on the denominator, we can move it up to the numerator by making that -4, and then we're still going to integrate that with respect to x. Now applying our rule, we still have this 6 out the front, so I can leave that here, and then we're going to divide that by the a term, which in this case is -5, so that's the coefficient of x, remember, so we're going to have -5 times, and the new power when we add 1 to the power of here when we had +4 it went to 5, but when we have -4, adding 1 to that will give -3. And then we're still going to have that multiplying 2 subtract 5x to the power of -3 once we've added 1 to that power. And then, of course, we would have that plus c, which is the constant of integration. And now we can just quickly clean this up before we put our final answer down. So this is going to equal, and 6 divided by -5 times -3 is 6 divided by +15, and that can actually simplify to 2 divided by 5. And then you would have 2 minus 5x to the power of -3 plus c, and that would be a perfectly acceptable answer. But you may also see that expressed as 2 divided by 5 multiplying 2 minus 5x to the power of just +3 now that it's in the denominator again. So we can move that power of -3 down here and make the power positive, and then don't forget that plus c. So either of that answer or that answer would be considered correct. So I hope that video helped. See below for more examples of questions like this, and make sure you stick around and have a look at part 4, where we're actually going to look at integrations that result in a logarithm, which is where we actually have a power that is equal to -1. So we're finally going to have a look at what we do when our power is equal to -1.